Hello students, welcome to IMS GATE Academy. Myself J.Jeprakash, lead mentor of EC branch at IMS GATE Academy. So in the last week, we have discussed regarding rank boost topic with respect to network theory subject. So that is KCL. Whoever might have missed that session, they can watch in their free time. And I and Vipin sir together, we are doing series of one series that is rank boost topic. So in this particular series, we are doing for various subjects with respect to your EC electrical IN, right, gate preparation point of view, whatever the important topics and most important topics that we are covering in our YouTube channel. Already Vipin sir has done few sessions regarding signals and system subject, control system subject, even analog circuits also. Okay, all of you can watch those sessions whoever might have missed earlier sessions. Okay, so all those videos, all those sessions are available in our YouTube channel. In your free time, you can kindly go through with respect to your branch, and accordingly you will be getting maximum benefit by watching this series of lectures. Okay, so in this series, in this session, we are discussing the next topic with respect to network theory subject, that is KVL. Okay, so this session is common for three branches: EC, electrical, and instrumentation. All of you can kindly like and share this video link with all of your friends so that they also will get benefited from this particular session, right? Whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and click on the bell icon so that you will be getting all the instant notifications whenever we are uploading any videos, or whenever you are having, like, we are conducting upcoming live sessions also. Regarding that, all the important updates you will be getting. Okay, you won't miss even single video, right? So this is my complete profile. Yeah, so these are in this particular gate 26. Okay, at our IMS GATE Academy, the two best ranks. Okay, yeah, these are the gate 26 achievers, gate 25 achievers, similarly gate 24 achievers with respect to at our IMS GATE Academy. Okay, yeah, whoever not yet joined our Telegram channel, the link is provided in the description of this video. All of you can kindly join. It is free for everyone. All of you will be getting all these important updates in our Telegram channel. Yeah, coming to the syllabus, I hope some of you already aware regarding network theory subject with respect to gate exam point of view. And whatever the syllabus is there with respect to network theory, when you are preparing for gate exam, definitely the syllabus, whatever the topics you are learning, concepts you are learning, it will be useful for your other PSU job exams as well with respect to network theory subject. Okay, so with respect to gate exam point of view, the weightage will be there around 8 marks with respect to EC, electrical, instrumentation, all three branches. And this subject is the basic subject, and application of this particular subject is analog circuits. In the analog circuit subject, while solving the questions regarding equivalent circuits, okay, so that time you will be using the concepts of network theory. So directly you are getting around 8 marks from this particular subject in the gate exam, around 8 marks, and indirectly with the help of network theory subject, you can score around 10 marks or 11 marks, even up to 12 marks if you combine with respect to analog circuit subject with the help of network theory concepts while you are solving some of the questions of analog circuit, right? So that much huge weightage you are getting with the help of network theory subject, right? So currently we are focusing regarding first chapter. So we already done the first topic, that is KCL. Now in this particular session we are discussing regarding KVL. Yeah, all of you can put the heading KVL, Kirchhoff's voltage law. Yeah, for the timing I have considered one circuit. Here in this circuit we are having a voltage source and then three resistors are there. How all these elements are connected? All of you can mention the chart. How all these three elements are connected. Yeah, here voltage source Vs, three resistors R1, R2, R3, all the elements connected in series, right? You are having one closed path. Okay, in series current will be same, voltage getting distributed. Okay, fine. Now because in this entire closed path you are having only one source, that is obviously it has to deliver the supply, right? So since we are saying this voltage source is an active element, okay, so here current will leave from positive terminal, here current will leave from positive terminal. Yeah, just 1 minute. Yeah, here current will leave from positive terminal. So let us assume the current flowing in this circuit is I. Okay. So with respect to passive elements, the current is analogous to water, right? So current always will flow from high potential to the low potential. So accordingly, current enters positive terminal. Here also current enters positive terminal. Here also current enters positive terminal, right? So whatever the current that I is flowing, okay, it will flow like this, right? All the elements are contained series, the same current is flowing. Okay, now you can write the KVL around the closed path. And while writing that particular voltage values, with respect to every component, you will be having two voltage polarities plus and minus. With respect to every component, you can consider second polarity, or with respect to every component, first polarity, while you are considering the closed path. Okay, so for the time being, I have considered second polarity, minus 2 plus Vs, then plus 2 minus V1, then plus 2 minus V2, then plus 2 minus V3 equal 0. Total 4 components are there. So with respect to every component, the second voltage polarity I have considered. Okay, so here if you bring negative terms to the other side, it will become positive. So you are getting Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. This is the equation number 2. Okay. From the equation 1, if you take minus as common, then you will be getting minus Vs plus V1 plus V2 plus V3 equal 0. After that, on both sides you can multiply with minus sign. 0 into minus 1 is 0 only. So accordingly you are getting one more equation, that is equation number 3. Now with respect to equation 3, when you observe the circuit, with respect to every component, we have considered the starting polarity. Okay, so whenever you are having the closed path, with respect to every component, you can consider second polarity or you can consider first polarity. But it's not that some elements you will be considering starting polarity, some elements second polarity. No, that time equation is not balanced. Okay, I hope it is clear for everyone regarding the KVL, how to write for the given circuit. Okay, right. Now, all of you give it a try. This is the MCQ question. Choose the correct option regarding KVL. Choose the correct option regarding KVL. Yeah, option A you are having, in any lumped electric circuit, the algebraic sum of voltage drops around any closed path is equal to 0. Whether it is correct or not. Option A statement, is it correct or not? All of you can mention in the chart. In any lumped electric circuit, the algebraic sum of voltage drops around any closed path is equal to 0. Yes, that is correct statement. Right. Next, regarding option B, KVL is independent of nature of elements. Here nature of elements means types of elements like linear, non-linear, active, passive, bilateral, unilateral, etc. Right? Is independent of nature of elements that are present in the closed path. Whether it is correct or not. Yes, this is also correct. Because the question is MCQ, among the four choices, only one correct choice will be there. So option C, if you observe, both A and B are correct. Yes, that option we have to mark. Okay, the correct answer for this question is option C. See, regarding option A statement is KVL definition. Regarding option B statement is whether KVL we can apply for the circuit where the types of elements could be anything among linear, non-linear, active, passive, bilateral, unilateral, etc. Yes, that is also correct. Okay, right. Now, all of you give a try. I hope everyone or most of you can answer this question correctly. KVL obeys law of conservation of what? Law of conservation of what? Energy. Very good. Law of conservation of energy. Okay. So first of all, consider the equation number 2 from the KVL when we have applied in the given circuit, earlier circuit, right? Vs equal to V1 plus V2 plus V3. What is the basic notation or formula for voltage? If you can recall, after that we can substitute in this equation and we can get the conclusion point. How we can write voltage? Voltage equal to dW by dQ, right? The amount of work done to bring the charge, right? So V equal to dW by dQ. In the earlier equation, in place of V, you can substitute dW by dQ and suffix whatever you are having, yes, 1, 2, 3. Accordingly, you can substitute. Right? Yeah, mention your name in the chart. Yes, you got correct answer. Very good. Just mention your name so that I can pronounce your name, right? Yeah. So here differentiation operator, first order differentiation operator is the linear operator, right? So we can write like this, right? After that, if you perform integration both sides, integration derivative both will get cancelled. Then from there we are getting Ws equal to W1 plus W2 plus W3, right? Yeah. So in this closed circuit, whatever the closed circuit we have considered, closed path, in that circuit only one supply was there. Remaining all the elements are passive elements, resistors, they are absorbing the energy, right? So in any closed path, whatever the net amount of supply was there, that will be distributed across the remaining elements, right? So that means it is satisfying. Matlab KVL obeys law of conservation of energy. See, in any closed path, like in the current example, we have considered only one, like in this particular circuit, we considered only one source. Suppose if multiple sources are delivering the energy, right? Whatever the net amount of energy was delivered, so that will be equal to the net amount of energy absorbed in that closed path, right? So here, voltage source is supplying or delivering the power, delivering the energy, whereas the resistor R1, R2, R3 are absorbing the energy, right? Yeah. I hope all of you know regarding law of conservation of energy. You might have studied right from 9th standard or 8th standard onwards, right? So energy neither be created nor be destroyed, but it can be converted from one form to another form. Like that, in this closed path, if you observe, like whatever the elements they are delivering energy, that net amount of energy will be absorbed by remaining elements. Okay, so that means KVL obeys law of conservation of energy. KVL obeys law of conservation of energy. That is the option B. Yeah, good evening, Suganya. KVL obeys law of conservation of energy. Option B is the correct answer. Yeah, this is an easy question. All of you give it a try. Whatever the KVL currently you have learned, try to apply that KVL in this circuit and what will be the final answer? V out. Yeah, in this circuit, 10 volt source, 2 ohm resistor, 5 ampere current source. How these three elements are connected? Any guess? How 10 volt, 2 ohm and 5 ampere are connected? Series or not? Yes, series only. How to say? How to say they are connected in series? See, here you can observe, like here terminals kept open, right? This terminal and this terminal kept open. So when terminals are kept open, no current will flow. No current will flow in the open circuit path. So whatever the 5 ampere current is entering, the 5 ampere current will go through 2 ohm resistor. Okay, will go through 2 ohm resistor and then 10 volt source. So in that way you are getting closed circuit. Okay, when the elements are connected in series, the same current will flow. Right? Yeah, very good, Savanya. Now here, yeah, so whatever the 5 ampere current is coming, the entire 5 ampere will flow like this, because in this branch no current flows, right? So whatever the 5 ampere is coming, okay, so with respect to Ohm's law, 5 into 2, that is 10 volt. That is the voltage developed across the resistor, and voltage polarity plus right hand side minus left hand side. Then the 5 ampere current is flowing through the 10 volt source, and then it is coming like this. Okay, and whatever 5 ampere is there, that is going, okay, in the vertical. So that means here no current flowing, right? Here in this branch also no current. Okay, right. Now just apply KVL. Just apply KVL around the closed path. You can write either clockwise or anti-clockwise. Either clockwise or anti-clockwise. With respect to every component, I am considering second polarity. If you want, you can consider first polarity. No problem at all. For the timing, I have considered anti-clockwise direction. With respect to every component, second voltage polarity. Yeah. So here minus 2 plus V out. Minus 2 plus V out. Then plus 2 minus 10. Then plus 2 minus 10 is equal to 0. So here you are getting V out minus 20 is equal to 0. Then from there you are getting V out equal to 20 volts. V out equal to 20 volts. Right? Yeah, 20 volts is there in option D. Option D is the correct answer. Option D is the correct answer. See, here we got the value of V out by using KVL. Okay, the same value you will be getting instead of writing the equation. Of course, whatever the notation, whatever the approach currently I am discussing, that is based on KVL only. But by following that approach, you can get the answer quickly. Okay, you can get the answer quickly. Say for example, here in this circuit, you have understood that across 5 ampere current source, we have to find the voltage. Now, when you observe that circuit, across 5 ampere to the left hand side, what configuration you are having? You are having 10 volt source in series with 2 ohm resistor. Right, regarding the corresponding voltages across 2 ohm we got. Now keep those voltage polarities one side, alignment you can keep accordingly. Then from there you will be getting resultant final voltage. Okay, what do you mean to say here? Like 10 volt source was there, you keep voltage polarities as it is, right? Plus minus 10. Now whatever the 2 ohm resistor is there horizontally, the voltage polarity here plus, here minus. That one you can keep vertical alignment. Then you are getting plus minus 10. Just like whatever the 10 volts was voltage polarities were there, exactly in similar way in this question. Now when you are getting voltage polarity same, plus minus, that means you can add. Suppose if plus minus is there, minus plus is there, we have to subtract. Okay, in this case we can add. So accordingly you are getting 20 volt. Okay, now this 20 volt you are getting across 5 ampere. That's all. That's all. Okay, in this way if you do, you can get the answer correctly without doing any silly mistake. Sometimes few students, while they are writing KVL equation, here and there, like plus and minus, they may do silly, they may write wrongly. Because of that, they can get wrong answer. But if you follow this approach, no need to have any confusion. You will be getting correct answer. In fact, you can get the answer quickly. Okay, with the help of this logic. When you are having multiple elements connected in the closed path. Okay. Yes. I hope it is clear for everyone regarding the second method. Right? Yeah. So the final answer for this question is option D. Next question, EC 97 for 1 mark. I am giving time for everyone. All of you can try their level best. So in this circuit, 2 ohm resistor and 4 volt source, how they are connected? I am talking about right hand side 2 elements, 2 ohm resistor and 4 volt source. They are connected in parallel, right? In parallel, which quantity will be same? In parallel, voltage will be same. That means across 2 ohm, you are getting 4 volt. 4 volt. Right. Now, the moment you got across 2 ohm resistor voltage, after that you can easily apply KVL either clockwise or anti-clockwise, your wish. Okay, for the timing I am considering clockwise. You can write in any notation, no problem. Okay. So here 5 volt source value no, 4 volt source value no, across 2 ohm resistor also voltage value we got, and across 3 ohm resistor we have to find out the voltage. Right. So with respect to every component, I am considering the second polarity regarding the voltage. Then you consider in the clockwise direction. Yeah. So here -2 plus 5, then +2 -4, then +2 -4, then -2 plus V is equal 0. Okay, -2 plus +5, +2 -4, then +2 -4, and then -2 plus V. So from here what you are getting, 5 minus 8, that is nothing but -3 plus V equal to 0. From here you are getting V equal to 3 volts. Yeah, sometimes few students will be very smart or innocent, we can say. So here when you are getting equation like this, V equal to 3V, okay, V getting cancelled. From here you are getting like 1 equal to 3. So with respect to basic maths, 1 and 3, how they are equal? Not possible, right? So because of that, here option D, some students may mark none of these. But such kind of questions, no, like with respect to here, this context I'm talking, okay, it won't be matching to that one. The reason is, in general, the exam paper setters will take care regarding the, like whatever the voltage value you are supposed to find out, the notation wise, okay, like V1, VA, etc. they will be giving. But surprisingly here, once in a while in few questions they used to give the notation wise regarding voltage, they will be giving voltage units or volts. Volts will represent like capital V. A very extreme case, it may match to like that. Okay, that time, just to avoid the confusion, what you can do, like instead of writing like voltage units or volts, like in short like V, instead of that you write volts. Okay, then there won't be any confusion. Okay, right. So here V equal to 3 volts. If you write like that, then there won't be any problem. V equal to 3 volts. That means voltage across 3 ohm resistor is 3, right? Yeah. So that is there in option A. Option A is the correct answer. Option A is the correct answer. Okay, this question also we can solve whatever the earlier I have given shortcut approach according. Okay, so here like across 3 ohm resistor we have to find out the voltage. Across 3 ohm resistor we have to find out the voltage. So whatever, like if you observe like 5 volt source, 4 volt and another 4 volt, you keep in such a way one alignment so that whatever the resultant voltage you are getting, that voltage will be across 3, correct? Just like earlier question. Now so here 5 volts voltage polarity have considered plus minus as it is. Now whatever 4 volt is there horizontal, keep vertical alignment, then you are getting polarity minus plus, minus plus. And whatever the 2 ohm resistor you are having, that 2 ohm resistor also regarding the voltage polarity, when you kept vertical alignment, then you are getting plus is coming at bottom, then minus at top. See if you are having any slight confusion whether plus minus or minus plus, very simple, very simple. With respect to first component, when you check here plus sign is there, here plus sign, okay, so those two side by side like that you can check. Then here minus sign, here plus sign, okay, like that you can check. The moment somehow there like one polarity you are able to represent correctly, obviously other polarity will be, you can easily represent, right? There won't be any confusion. Now in this case you are getting like plus minus combination, then minus plus, right? So regarding minus plus, two values are there, 4 volt, 4 volt. So since polarities are same, we can add. So accordingly you are getting minus plus 8, and regarding plus minus as it is 5 volt. Now in this case, in order to find out the resultant voltage, one polarity is having plus minus sign, another one is having minus plus. When you are having opposite, we have to perform subtraction, right? Like from where to where we have to separate, obviously you know smaller value can separate from larger, so accordingly larger value polarities will be getting. In this case 8 is the larger, so resultant polarities will be getting minus plus. 5 you can separate from 8, so 8 minus 5 is 3. Now if you compare with respect to 3 ohm resistor, yes, across that we are getting exactly same polarity, minus is matching, plus is matching, so V equal to 3 volts. V equal to 3 volts, that is there in option A. V equal to 3 volts, that is there in option. So based on your convenience, if you want to write KVL equation you can do, or if you want to follow this approach based on your convenience, you can go ahead. Okay. Yeah, next question, very very interesting question. All of you can give it a try. All of you can give it a try. I am giving time for everyone. And mention your answer in the chart. Mention your answer in the chart. Don't hesitate whether your answer is correct or wrong. If you are able to answer correctly, I will appreciate. If you are getting wrong answer, I will double appreciate, because when I discuss the explanation part, you will be getting the opportunity where you might have done calculation mistake or silly mistake, or even if you understood the question wrongly. Okay, because you are getting opportunity to update yourself, right? Don't hesitate while trying the question whether your answer is going to be correct or wrong. Keep that one aside. Okay, just give your effort, give it a try, that's all. Yeah, for this question, whether anyone is going to mark like option A? Yeah, in general, many of the students will mark option A. Okay, or some of you may mark option C, but both are not correct for this question. Any guess? Why option A, option C are not correct? Why in general, many of the students, while they are solving very first time this gate question, many of the students may mark option A and few students may mark option C, but both are wrong. Both are wrong. Because while they are marking either option A, they might have considered the result 2 ohm resistor and 5 volt, that much voltage only. Okay, if they considered polarities wise correctly, then accordingly option A. If they considered polarities wise somewhat wrong here and there, then accordingly option C. But both are not correct, because here they are asking voltage with respect to two terminals. Left hand side, if you see, one rectangular box is there, that means one network. Okay, because we don't know what is there inside that block, we cannot find the voltage from the left hand side network. But in this circuit, we can find out the voltage across those two terminals with the help of right hand side part of the given circuit. We can write the corresponding voltage by using KVL. Right. Here 2 ampere current is flowing through 2 ohm resistor and the 5 volt source. Now by using Ohm's law, across 2 ohm you are getting 4 volt. Okay, now 4 volt, 5 volt. They will be adding because voltage polarities are same, accordingly 9 volt, or if some of you might have done silly mistake, 4 volt they will separate from 5 volt, that is 1 volt. But both the options are not correct. Option A not correct, option C not correct. The reason is they are not asking with respect to the rightmost side two elements like 2 ohm resistor and 5 volt source. Across that, if they ask the voltage value, then option A is correct. But across that they are not asking. Rather, after considering 2 ampere current source along with 2 ohm resistor and 5 volt, that whole configuration across that they are asking the voltage. Right. Here the twist is there. When you know it is a current source, that means you know only the current value. 2 ampere source, 2 ampere current is producing by that source. But do we know the voltage across it? No. We don't know the voltage across it. The voltage value could be anything. But because it is a source, in this particular example, accordingly I have considered the voltage polarity. As we have mentioned, whenever you are saying any element is a source, it has like current has to leave from positive terminal. So accordingly I have kept the notation. Okay. But whether in this circuit, whether the 2 ampere source is acting really as source or not, that finally when we got that particular voltage, if polarity wise matching, then it is the source only. If polarity wise you are getting negative, then it is acting as a, like it is absorbing. It is not like delivering the power. Okay, fine. But for the timing I consider with respect to delivering wise. Okay, so now you can write the KVL. With respect to every component, I have considered the second polarity. -2 plus V, -2 plus V to A, then +2 minus -4, +2 minus equal to 0. From here, what you are getting, V equal to 9 minus V to A. Unless otherwise, we know the voltage across 2 ampere source, we cannot give the conclusion. Suppose if voltage across 2 ampere source is 0 volt, then accordingly you are getting 9. If voltage across 2 ampere source is 8 volt, then accordingly you are getting 1 volt. If voltage across 2 ampere source is 4 volt, then accordingly you are getting 5 volt. So unless otherwise you know the voltage across current source, we cannot tell the voltage across that whole configuration of the right hand side 3 components, right? That is the reason in this question option D is correct. None of this. Okay, it is a very, very interesting question, and that too this question asked in the year 1997, one of the old gate question, right? So the exam paper setter, whoever IIT professor has created this question in that year, so I saluted like anything when I see this question. Okay, for discussing with respect to our enrolled student, right? I started my career in the year 2015. So right from like in that particular year when I taught this particular subject, so while selecting the good questions, so I figured out this question, and this question is very good question in such a way See, everyone knows the basics regarding KCL, KVL. Even average student knows that one, but right from average student to the even topper, 90% of the students, at least 90% of the students, they will be attempting this question very first time wrongly, very first time. But whoever might be having very alert, cautious about the circuit representation, everything, only those students can solve this question correctly. Okay, yeah. Yeah, next question, electrical 2004 2 mark. In this way, with the help of gate questions while you're solving, with the help of gate questions or any standard questions when you're practicing, so with the help of some questions, you'll be getting like how to apply that method or concept, and you'll be focusing on try to get the correct answer. And with the help of some questions, you'll be getting some insights or key points. Okay, that will create the difference, or that will create the like interest while you are learning that particular subject or preparing for that particular subject. Yeah, in this question you have to find out the voltage source value, that is E. Now all of you look at the circuit. What is the first step? What is the first step in this circuit? While solving this question, what is the first step you will do? See here, 1 ampere current source is there from the left hand side, and 2 ampere current is flowing. Okay, now you can apply KCL. Yes, sir. You can apply KCL. See here, 1 ampere current is entering. Okay, suppose I am labeling this is the node A and this is the node B. Suppose, right? At a particular node A, right, 3 branches are there, among which in 2 branches currents are entering. 1 plus 2, together 3 ampere. Obviously 3 ampere has to leave from the node through other branch, right? Yeah. So that is the KCL. That is the first step. Now after that you can use Ohm's law. According you're getting across 6 ohm corresponding voltage. So here 2 ampere is entering, so 2 into 6, 12 volt. Then here 3 ampere is entering, accordingly voltage polarity plus minus, 3 6 are 18 volt. Now you can apply KVL. All of you give it right. What is the value you are going to get? Yes, you will be getting option C, 30 volt you will be getting. Okay, 30 volt you will be getting. You can write KVL equation, or otherwise you can use the notation which we have discussed, right? So here 1 voltage source is there, that value we have to find out. On the right hand side, if you see, you are having 18 volt vertical element as it is, you can keep, and whatever the 12 volt is there horizontal, keep vertical element, then polarities are, you are getting exactly similar, plus minus. Since you are getting same polarities, you can add, that's all. So final value is going to be 30, that is there in options. Even if you write KVL, you will be getting same answer. Okay, I hope it is clear for everyone. If any of you are having any doubt, you can mention the chart. Yeah, that's all in this party session. In the previous session, we have discussed regarding KCL, and in this session, we have discussed regarding KVL. If any of you are having any doubt, just mention the chart. I will be clarifying. Meanwhile, I will be giving some important updates. Right. whoever not yet enrolled at our IMS GATE Academy, but whoever want to, like whoever kept the aspiration to get PSC job or to do MTech at world IITs or world NITs, etc. So if you want to get very good opportunity through the GATE exam, definitely I can say the coaching will help you, right, in order to achieve your result, in order to achieve your target easy way, in effective manner, I can say. So that is the reason whoever interested, like to get very, good opportunities through the GATE exam. So whoever not yet enrolled at our institute, they can book free counseling session. The link is provided in the description of this video. Our education advisor will discuss the complete details regarding, with the help of GATE, whatever the opportunities are available, and at our institute, whatever the available programs are there, you will be getting complete details, and whichever program is suitable for you, accordingly you can opt for that, so that you can easily do the effective GATE preparations. Through that, you can get whatever the dream that you have kept, that you want to achieve through the GATE result. Okay, right. Yeah, whoever not yet joined our Telegram channel, the link is provided in the description of this video. All of you can join. It is free for everyone. You will be getting all these important updates. You will be getting in our Telegram channel. Yeah. So tomorrow, right, tomorrow we are having one live session regarding rank booster topic series continuation, series connection. Okay, next topic is series connection with respect to passive elements, with respect to active elements we'll be dealing. Okay. So timings are same, 4 o'clock onwards, right? And day after tomorrow, that is on 11th, right? We started one series in the last month regarding digital circuit subject, right? Doubt solving session we are doing right from the first chapter. So one session every week we are conducting live session. Chapter wise, what are the doubts? Like whoever enrolled at our IISc Academy, after attempting respective chapter test, what are the doubts they are having? Those doubts I have discussed in the live sessions. So in that way, like whoever already attempted those tests, what are the doubts they are having? Through that live sessions, they are getting benefited. And whoever not enrolled at our institute, with the help of these doubt solving sessions, whoever having basic idea, at least they are getting to know the method of solving, etc. We already done good number of sessions, right? 5 sessions already completed, weekly wise, weekly one session we are doing. So like that, 5 chapters, right, from number system and codes, Boolean algebra and K-maps, logic gates, then combination circuits, sequence circuits. First 5 chapters, chapter wise, one session we have done doubt solving part, right? Whoever might have missed those sessions, kindly watch in their free time. And with respect to all the 4 branches, EC, electrical, instrumentation, computer science, the first 5 chapters are equally important. So that is the reason chapter wise doubt solving I have kept only first 5 chapters. And day after tomorrow, that is on 11th June, we are having 11th June, and similarly next week, Thursday, we will be having 2 doubt solving sessions, like session number 6 and session number 7. Those two sessions related to the digital circuits entire subject, what are the doubts you are having, that doubts will be covering. So whoever already enrolled at our institute and whoever attended our classes and given the basic subject test, in that basic subject test, what are the doubts they are having, that doubts I will be covering in the live session. But in the course of time, in the live session, if you are having any doubts with respect to oral subject, all of you are getting equal opportunity. Whoever not enrolled at our institute also, they are also getting opportunity subject wise. Okay, what are the doubts you might be having, that we can discuss, right? Now on 11th June session, live session, and similarly next week we are having one more session. With that, we'll be completing regarding digital circuit subject doubt solving session spot. Okay, and not the least, in this week on coming Friday, that is on 12th June, with respect to rank booster series, we are having parallel connection, right? So regarding parallel connection with respect to passive elements, parallel connection with respect to active elements, right? So in this way, what are the live sessions we are doing? Okay, based on the possibility, try to attend the live sessions if possibility, and due to any reason if not possible, you can watch them later. Okay, so all the sessions whichever we are doing live sessions, those will be available even after the live session complete in our YouTube channel, right? Yeah, so all of you can like and share this particular information with all of your friends, so that whoever really are sincerely preparing for any of the competitive exams like GATE, either GATE exam or any other PSUs, etc., definitely they also will be getting benefited, right? At least basic knowledge wise they will be getting, right? Yeah. Yeah, keep learning and keep growing. Try and fail, but don't fail to try. Yeah, that's all in this particular session. We'll meet you all on tomorrow. Thank you. Thank you, everyone.